Now, in addition to the Pearson correlation, we also have the Spearman correlation. So far when I've talked about Pearson's R, I was talking about a correlation coefficient which measures the relationship between two continuous variables, that is, two variables that are either on the interval or ratio scale. Now, the Spearman correlation is used when you're measuring the relationship between two ordinal variables, or you're measuring the relationship between two variables that are related, but not in a linear fashion. Like, look at this right here. You can obviously see that whatever x is and whatever y is, there's some kind of relationship, but it's more curvilinear. It'd be more difficult to draw a line through that. But you also couldn't say there's no relationship because there obviously is one. So we would use something like the Spearman correlation to calculate that. So here is a sample data set. We've got some ordinal data here, 6 x's and 6 y's. Now, what we need to do with the Spearman correlation is we must first rank the scores. So I'm going to replace the score with what rank it has. The lowest score has the lowest rank, and the highest score has the highest rank. So 2, 5, 8, 11, 15, 16 turns into 1, 2, 3, 4, 5, 6. And the same for y. So now we're just going to forget about the original data, and we're just going to deal with these ranks. And we're going to calculate this r, which should look a lot like a regular r. Just now we have ranks instead of raw scores. So let's create our xy matrix, and let's start working through this. First, I'm going to find the sums of all of our columns. So the sum of all x is 21, sum of all y is 21, and the sum of all xy is 56. So let's get started with this. We can replace n with 6 because we know that there are 6 people in in the entire analysis. And then we can put in 56, 21, and 21 because those are the sums that we already found out. We just need to find the bottom part of the fraction now. So we can put in the 21s there, and we need to find out the sum of all x squared and the sum of all y squared. So the sum of all x squared is each individual x squared and then added together, and the same for y. It's just each individual y squared and then added together. So both of those add up to be 91, and we can put 91s into the equation. So this is a little bit easier than a Pearson's R. These numbers are definitely easier to find. And now that we have this, we can work through it and solve for r, which, believe it or not, is negative 1.00. We have a perfect negative relationship, which should make sense looking at the x's and y, because every time x goes up 1, y goes down 1. That is a perfect negative relationship. So we're going to say that x and y have a strong negative relationship, whatever they are, strong negative relationship, using the Spearman correlation for ordinal data for ranked data.